Okay, now let's have a look at the torque diagram. Imagine there is a composite structure. The composite structure might be the structure made up of like two different materials. That is material 1, that's material 2. Or it might be they are the same material with two different diameter of that one. If we want to find out the equilibrium forces, now here, if you have a look, we use a right hand rule. Like let's say it's right hand, I'm just turning it that way, yeah, and I'm just that is fixed here. Imagine that is fixed here at the A and that's fixed at the C. Now if I'm applying a force, I'm trying to twist that one that would be clockwise. I'm trying to twist it clockwise at the B. These at the C and the A will have to apply the reaction torque, which will be in opposite and opposing direction. So here the torque is going to be anti-clockwise and that will be anti-clockwise. This because these are fixed. And here what I'm doing, I'm trying to apply the torque. Okay. Now, then what you're going to do is if you apply the torque diagram, because this is, we use a left-hand rule for the applied torque, where X is we use for the thumb, Y is the first finger, and Z is the middle finger. Yep. So now if I want to find the torque, in this case, the easy way to do that one is because this is anti-clockwise. You can see it's going up, right, that notation. This one is going to be a clockwise, so it's going to be down. But this has to be balanced by the one that's here. But because the diameter of this one is bigger, it can take more. So hence, that's going to be less as compared to that one. We will do numerical question, will make more sense. Again, we got if we want to find out the angle of twist, we use the same formula, but this time we're taking an angle. So this is the formula for the angle of twist. Theta equals to TL over J. This is the formula. Now, the angle of twist at A should be the same as angle of twist at C. Okay. Now, next one. Let's say we got an example where first diameter, there are two rods together. Let's imagine they are made of the same material. The first rod is 20 millimeter. The second rod has a dia of 40, double. The length of the first rod from here to here is 300. The second rod is from here to here is 500 millimeters. They want us to find out the maximum torque. Maximum torque when the shear stress is given 75 megapascals, 75 newtons per millimeter square. Now, Newton per millimeter square, everything is millimeter, we keep millimeter. So we have a formula. A1, we're taking that one as first one and that one as second one. So A1 over J from A to B, J of that one should be equal to, we want to find that one should be equal to, which is that formula. Theta angle is same as A over J. That should be equal to 300, where we got the 300 from, times the tau A divided by JAB. Okay. Let me write the formula. A1 over J equals to LTA over the J. The J and J cancel. But I'm still writing it down. Okay, this is the formula. This is the JAB and this is the JAB as well. Where L is the length, this is the formula. L is the length, TA is the torque at the A, JAB is a inertial second moments, J. So we put that one. We have the same for the other one. Now we know this is the theta 1 and this is the theta 2, the angle of twist. Yeah. So if I make them equal, because they are equal, a1 over that should be equal to a2 over that. So which mean this side, if I color that one, this side should be equal to that side. I make them equal. I make them equal. Now I can make because the question is finding the maximum tau. I can rearrange the formula to find the maximum tau. How I can rearrange the formula? Okay, the maximum tau is going to be at torque A, this side, rather than this side, because the A can is smaller, it can take more torque. So I can do, let's do this one, TA over, now 300 is there, divided by JAB equals to 500 torque at C divided by JBC. Yeah, so now they're different. I need to make this thing a subject. If I'm making this thing a subject, I cannot move that one, but everything else I can move. So that is a 500 torque C over JBC multiply by this 300 is up, it comes down. This JAB is down, it comes up. Yeah, if we flip on the other side, and that's equal to T, the property A. Yeah, and that will be what we got. Now what I'm going to do is I will put the values and get the answer. So once I got that one, I need to find out the value of the JAB. I need to find this value. It's pi over 2 times R4. Yeah, the formula for the J is pi R4 over 2, where R is a radius, the I is 2, radius is 10. That will give me a value in millimeter. For this one, same formula, pi R4 over 2, 40. So put that one, get the answer. So I got two answers, that one and that one. Now I can put straight in this formula. I got the value, 500 is there, 300 is there, I got this JBC, JAB. The only thing I don't have is this value. That has to be, yeah, torque C, okay. Now I need to put the value. So now I don't have that torque C value. Let me just color code it. Every value is there. That value is the one that's missing. I put everything there, yeah. So now I got TA equals to 0.104 TC. But I don't have the TC. So to do that one, I know the total torque should be equal to the torque A plus torque C, because that is how it worked. Now the torque A is actually equal to, which is here, torque A is 0.104 TC. So instead of torque A, I put 0.104 TC. That plus that another 1 TC will give me 1.104 TC. Yeah? But I still don't have the value. Now that means if I got if I need to find out the TC and I need to find the TA, because I don't know which value is which. If I need to, I got this value now, T is equal to that one. So instead of T here, if I put this value, that will give me a value for the TC as 0.905 and the TA as 0.942 TA, because now I put that value back. So now I can have a look at torque at C. I don't know what the total torque is. Torque at C, which is 0.9, and the torque at A is going to be 0.09 of the total torque T. We don't have the value, but we can put the value if they give us a total value. Yeah. Okay. Now let's have a look at next part. We have this value 75, yeah, initially. So now I need to find out the torque at A. The torque at A has a formula, torque property equals to the moment thing multiplied by the tau over the radius of the rod AB, the small one. This will give me a tau. I put this one. This value I already calculated. Where I calculated? Here. I put that value. I put the value here. This one is this value 75. I put the 75 there. Yeah. R radius, I put the radius of this one is 10. I put the radius. This value, I don't know the exact value, but I know TA is 0.0942 T. So I put that one here. Now I need to find out the T. So to find out the T, what I can do is this whole thing, I can pick it up, put it down there, divide it. And when I just put this in calculator and this thing also here, that will give me an answer of 1.2 kilonewton meters. That will be the answer. The answer you will get is 1250, but you can convert into kilonewton. Okay. Now, if I have a look at the other one, if I want to check the other bit, TC. Now, the TC, I put the same, JBC times T. Now, that was calculated already, 25.13, where it was calculated here. I just get this value, multiply by the torque, which is 75 newtons per millimeter square, and then on, oh no, sorry, it's the next page. No, it's that page. Here, I think that's a mistake. If someone got a calculator, please. Instead of that one, can you put 20, please? And instead of that, sorry, there's two mistakes. So that's supposed to be, can I just double check? So it said C9058. So no, that's right, 9058. No, that is right. So that has to be a 20. If you put that in calculator, that's supposed to be 20, please, not 10, because the radius is 20. Yeah, can I borrow the calculator, please? Just to, when you put this 10 to the minus 6, the reason this 10 to the minus 6 appears, actually do not put the 10 to the minus 6. It's unit conversion, do not put at the start. When you put 25.13 times 10 to the 4 multiplied by 75 divided by 20, that will give you, this is 20, that will give you answer something like, and then divide it by 0.9058. That will give you the answer equal, oops, no, mess up the answer, 101040492. Yeah. Now this is in Newton millimeter. Yeah, Newton millimeter and over millimeter square. So you need to convert that into back. So you need to multiply it because that's millimeter square. Yeah, that's 75. Yeah, to do that one, you need to actually bring that back by 6. 1, 2, 3, 4, 5, 6. That's where you need to put a decimal. The first decimal is for the first decimal comes here, which will convert that into meters. So that becomes a Newton meters. Then you move 3 more back here, here, here. And that will convert Newton into kilonewton. And that will be your answer, 1.04. Then if I want to refine the T maximum, so T critical is the smallest stress, which is 1.04.